Today we're going to be talking about converse of the Pythagorean theorem. We have already talked about this again as we did our introduction into chapter 8. You will notice that this is still in section 2. So the Pythagorean theorem stuff that we did yesterday, along with its converse, are part of section 2. So the Pythagorean theorem's converse says if the sum of the squares of the lengths of the shortest sides of a triangle is equal to the square of the lengths of the longest side, then the triangle is a right triangle. Better would probably be just this for your notes. If a squared plus b squared equals c squared, then triangle ABC is a right triangle. So again, as long as, if you know three sides of a triangle, then the sum of the squares of the two shorter sides that are equal to the longer side, then it must be a right triangle. The Pythagorean inequality theorems. So again, you can write out everything. You should read it. If the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. And if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is an obtuse triangle. Again, kind of like before these two statements, though I will say, personally, I prefer, instead of c squared is less than a squared plus b squared, I do like a squared plus b squared is greater than c squared for acute, and a squared plus b squared is less than c squared for obtuse. Either one is fine. I like the one that I wrote a little bit better, only because when we think of Pythagorean theorem, usually we think of a squared plus b squared, so this changes the least amount of stuff for us. The other way is only better because of the symbol. So c squared is less than for acute, so it's less than, which kind of leads you to kind of see how c being smaller, if the length of this side is smaller, then this angle is going to get smaller. That's a bit of a simplification. We did talk about this already. So I'll give or try to give a brief example of this, if it will let me extend my page a little bit here. If we had a right triangle with sides of 3, 4, and what would our third side be? So hopefully we know it would be 5, right? 3, 4, 5 is a right triangle, Pythagorean triple of numbers. With that, if you didn't know that, you could use the Pythagorean theorem if I only gave you 3 and 4. So what would happen, and that's what these two theorems, or this theorem is talking about, two theorems are talking about, if we kept the sides 3 and 4, 3 and 4, but we made this side 6, right? What happens is that this angle has to open up, right? It hinges open like a door, right? It's being pushed more open. So I use the word hinge there, not as like another word, but because we have a theorem, the hinge theorem that we talked about in a previous chapter, that if two sides are congruent in one triangle and the third side of one is bigger than the third side of the other, right? It talks about the angles, this angle having to be bigger. So here then, if we had 3 squared plus 4 squared would be less than 6 squared, so this triangle would have to be obtuse. Again, we know that because if it's a bigger angle than the first triangle I drew, then it must be greater than 90, making it obtuse. We could use the same argument. We used 3, 4, and just to keep the side a little bit different, um, let's say 3.5, right? So this side and this side are congruent to our original triangle, but then the third side is smaller, right? 3.5 is smaller than 5, right? So then when we look at the angle across from it, it must be smaller than 90. So that would make this one, ooh, sorry, this is a bad example. Let me fix it. It's not difficult to fix. 4.5. All right. Now it fits the theorem. So if we had 4.5 across would be a smaller angle, right? Just a quick note. I don't know that we would have caught it. This number that we're using for C has to be the biggest of the three, right? So 4.5 is still smaller than 5, but 3.5 wouldn't have worked because it's smaller than 4, making it not the largest angle. All right. Sorry about that if that caused any confusion at all. So what I just did, though, is showing that these two theorems are what they say they are, right? It's a simple proof based on the hinge theorem. We're not going to do more proof than what we just did by example. That's it. All right, so we did all of this in class already before we left. We talked about this. It was actually probably what seemed like we got the best. So all we're doing here is setting this into our Pythagorean theorem. Now, you might notice I'm using a question mark above the equal sign. It's because I do know, but we don't know whether or not these two things are equal. So for now, it's better than leaving a blank space. We get confused then about what we're doing. So putting it as a question mark with an equal sign just to give us some spacing. When we get to the end, if we need to change it to a greater than or less than sign, we will. So we have 7 squared plus 24 squared. And as a note, we don't really care what 7 squared is or 24 squared is. We just care about what their sum is. So we get 625. And 25 squared is also 625. So 7 squared plus 24 squared is equal to 25 squared, which means that this is a right triangle. As you go along, I would strongly suggest that you do the calculations so that you don't get on your own and realize all of a sudden that you thought you knew what you're doing, but in the calculator you're doing something weird. So I would strongly suggest that you actually type in 7 squared plus 24 squared, make sure that you get 625, and do that with all of these problems so that we're making sure that everything's the same, so there's no like weird thing that happens when we get to doing this on our own. All right, number 2, we have 8 squared plus 14 squared, and we want to know if that equals 20 squared. I want a question mark there. I actually don't think that this is true. 8 squared plus 14 squared is 260, but 20 squared is 400. And I think all of us know that 400 is bigger than 260, or 260 is less than 400. So 260 is less than. Again, remember the symbol, the side that has 1 point, it's pointing at the smaller part. And then you can think about it a few different ways here. There are 2 ends here, right? That's more than 1. So the bigger side is on that end. Other people I've heard talk about it as like an alligator. If an alligator is hungry, it's going to eat the bigger of the 2 numbers, right? It's going to eat the 400. So think about it as a mouth. You can do that too. All right, here, that means that c squared is bigger, right? That third side square is bigger than the other 2 sides. That means that angle is going to open up, right? So it's going to open up and become obtuse. And I'm in class, usually I make you do the next one on your own. This is the same kind of problem on why Jacob needs to let me shave his head at some point, if you remember. So the problem with number 3, you haven't figured it out yet. You could go in and do it. It will give you an answer. It's just that the answer is going to be wrong because 12.5 plus 13, the actual sides, not the squares, is less than 26, right? So any two sides of a triangle have to sum to be larger than the third side. That doesn't happen, so this is not a triangle, right? Not a triangle. As a note there, the only time, so if you make a mistake and you do all of the work like we did on the last two, the only ones that you would kind of need to go back and check would be is if it comes up to obtuse. If it comes up to right or acute, it's fine. They're definitely correct. On a triangle like this, where it's not a triangle from given sides, it will always, I believe, always give you obtuse as your answer, as your wrong answer. So maybe just double check your obtuse ones. Like the last one, we had 8 plus 14, that's 22. 22 is bigger than 20, so we can make a triangle. All right, I can hear the moans of seeing this problem already. Why did we have to throw square roots into the problem and whatnot? So that's fine. We need to look at them. I told you they were going to be in this chapter. So the first thing we have to do here is actually decide which of these is the largest number. So is 4 the biggest number? Is square root 7 the biggest number? Or is 3 root 2 the biggest number? Because we have to have the biggest number as our C value, right? And then A and B have to be the 2 smaller ones. A quick trick here, the square root of 7, well, 7 is smaller than 9, and the square root of 9 is 3. So the square root of 7 is less than 3. It's definitely not the largest side, right? So 3 root 2 would be the other question. And you might just type that into your calculator, 3 square root of 2, which is 4.24, about. And that is bigger than 4, so that is our biggest number here. That's our C value. And the second thing then is just to make sure that these can create or make a triangle. Again, there you might need to go and actually find that the square root of 7 is about 2.64 or 65, right? And 2.65 plus 4 is bigger than 4.25, so we're fine there as well, right? So we have the square root of 7 squared plus 4 squared. Again, those are the 2 smaller sides. And then we have 3 root 2 squared. The square root of 7 squared, remember, a square root and a square, we call them inverse functions. And inverse functions undo each other, right? So we're taking the square root of 7 and we're squaring it. We get 7. 4 squared is 16. And then we have 3 root 2 squared. So a few things about this, we can look at a few different ways. One of them is that we can actually say that this is the same as 3 squared times root 2 squared, right? So an exponent over multiplication, we can, what looks like, kind of distribute that 2. 23 equals, but now I'm thinking we probably should have put a question mark in there, equals 9 times, again, the square root of 2 squared is 2, so 23, that is bigger than 18. Since a squared plus b squared is bigger than c squared, right? C squared is smaller, think c is smaller, right? And that would give us a smaller angle across from c. or an acute triangle. All right, at any point for the rest of this, you might pause the video at some point, work on a problem or two, for sure on the next slide, but if you're still trying to make sure that you're doing stuff right, you might follow along still on the next two. But we only have 5 problems left, so again, you may just pause the video and do them and decide if you can get the correct answer. I'm going to encourage you to do that before we start number 5. So number 5, again, 20 squared plus 21 squared. We want to know if that's equal to 29 squared. That's 400. 21 squared is 441. Is that equal to 29 squared? 841. Well, 841 is equal to 841. So this is a right triangle. If you paused the video and started working on number 6, I hope that you didn't do all of the work. Again, this is one of the ones that we need to check. We have 32 plus 35, that is 67. 67 is less than 70, which means that this is not a triangle. They sneak up on us, but that should be the first thing you check. All right, before I do these, definitely pause and do them on your own, and then you can come back and check to make sure you're doing them correctly. So pause now. When you're finished, then come back and we'll do them together. We have 10 squared plus 11 squared. We want to know if that's equal to 20 squared. $221 is less than 400. Again, c squared is bigger. Think like, the c is always a bigger value, but think that c is getting bigger than it was if this were than if this were a right triangle, right? So if this were a right triangle, c would be less than 20, right? But c is bigger than whatever that would have been, making that angle bigger, and we get obtuse. Number 8. Did we catch it yet? Giving you a pause to actually look at it again. 12 plus 14 is 26. 26 is less than 49. This is not a triangle. Five root 2, 10, and 11. Again, since we don't know off the top of our heads what the value of 5 root 2 is, we should plug it into a calculator. It's about 7.1, a little bit less than 7.1. So it is the smallest value. So we have 5 root 2 squared plus 10 squared equals 11 squared. 5 root 2 squared, 5 squared is 25. Root 2 squared is 2, so we have 25 times 2, which is 50, plus 100. Does that equal 121? No, it's much larger than 121, so this is acute. Again, it's the c squared we're looking at. C squared, this value is less than 150. It's smaller than 150. So that means the side C is smaller than it would be than if it were in a right triangle. So if that side across from the largest angle is smaller than it would be if it were 90, that means it's getting smaller than 90, making it acute. All right, that is, I think, all of our notes for today. Page 552, numbers 6 through 8, 21 to 26, 28 38, 53, 57, and 62 is your homework. That is due tonight at 8. Most of it is what we were just working on, so I don't think it's going to take a long amount of time. Some of the other problems are some review type problems from other previous lessons and stuff like that. There's also going to be a survey on Canvas that should be done by 8 p.m. tonight as well. It's just a few questions trying to help me gauge and figure out better ways for me to run this for you for next week, trying to see how it went this week, and kind of making sure the workload is an appropriate amount and everything like that, because it's definitely not my intention to make things difficult. I'm actually hoping that through this process you can find at least something that you like about doing the class this way, though it's definitely different. So check out that survey. Some of the survey questions are just more or less making sure that you know what's available and what's there, and how to do things so that moving forward it's smoother for me with grading and everything like that. But again, some of it is going to be just how you're doing for this class, what you think might make it better. All right? You'll notice that with that being the two things due tonight, there's nothing for you to do over the weekend for my class. So as much as you can, enjoy your weekend.